A normal Friday afternoon in rural Essex is torn open as a violent shockwave rips through the agricultural landscape. The time is exactly 4:50 p.m. on July 24, 2026. The location is an industrial unit tucked away on Southend Road in East Hanningfield. First responders catch the dispatch and roll out, expecting to tackle a standard commercial structure fire. But emergency crews approach these specific sites with extreme caution. A fire inside an industrial park carries an exponentially higher risk of catastrophic escalation compared to a typical residential blaze. 37,000 industrial fires break out yearly. Inside, processing generates combustible dust suspended in air currents, awaiting ignition. Below the dust sit flammable liquids and pressurized gases, accounting for 40% of fires, primed to ignite from a single spark. Then there is the physical footprint of the buildings themselves. These facilities feature massive, interconnected architecture with continuous roof lines, allowing flames to jump rapidly from one unit to the next without hitting a firewall. When the first crews arrived at East Hanningfield, they faced a highly unpredictable chemical reactor. The flames rapidly breached the walls of the initial unit, spreading across the adjacent industrial structures and jumping outward to ignite the neighboring farmland. The emergency response scales up immediately. Over 100 firefighters arrive on the scene, backed up by specialized hazardous area response teams. Recognizing the severity, Area Manager Dave Bond implements an immediate tactical shift, ordering the closure of Southend Road and beginning the evacuation of nearby residents. At this massive scale, the primary objective moves away from extinguishing the flames. The crews pivot to perimeter containment, sacrificing the compromised industrial units in order to protect the civilian community. The strategy is tested when the blaze reaches a unit storing agricultural fertilizer, triggering a massive, violent detonation, throwing dark smoke and debris skyward. The culprit is a common chemical compound found in many industrial fertilizers, ammonium nitrate. This animated diagram illustrates the science of thermal decomposition. When subjected to extreme heat, solid ammonium nitrate molecules do not simply burn. They rapidly break down and expand into highly pressurized gases, creating a devastating outward force. The resulting shockwave rattles windows across the county, prompting authorities to officially declare a major incident. This single blast confirms the ultimate danger of fighting industrial fires. Because it is nearly impossible to predict the exact chemical inventory of every storage unit, every step forward for a firefighter is a gamble. By 9:30 p.m., the fire is finally surrounded and under control. The physical operation slowly scales down, dropping from 100 firefighters to 50, and eventually leaving a crew of 25 by the following morning. Those remaining crews begin the long watch. They spend the next several days intensely monitoring the wreckage for hidden thermal hotspots. Industrial materials have a tendency to trap extreme heat deep beneath the surface rubble. These deep-seated embers can smolder for hours or days, waiting for a fresh supply of oxygen to reignite. True containment is not achieved when the visible flames disappear. The site is only secure when these invisible thermal threats are completely neutralized. The destruction at East Hanningfield stands as a stark reminder of the extreme volatility inherent in industrial zones and the constant need for rigorous hazard management protocols. Yet the operation also highlights the tactical precision of the emergency crews, who successfully contained a massive chemical blast zone without a single fatality. For the ongoing investigation into the fire's origins, and for real-time reporting on the capital's biggest stories, visit